Hey, it's W5HRO. Well, I've got this thing all built. The only thing I have left to do is I need to wire up the two pots and the mic jack, and that's going to be, I'm going to do that tonight, or maybe I'll wait till tomorrow morning, but I'm getting ready to take this thing. I'm going to put the front panel back on it tomorrow, and this is the new meter, by the way. It's a little bit shorter scale. It doesn't go to 250, it goes to 200 instead, which is better, but each tick mark is 5 milliamps instead of 10. So it threw me off for a minute. I went, oh, wait a minute. Those are 5 milliamp tick marks. So what I'm doing is when I go to test, when I go set the current on one of them, all I have to do is unplug one of these RCAs in the transmitter. And see, there's one side, there's 40 mils. And then the other side I can pull up, and then I set that one for 40 mils, and there you go. I might wind up setting them both for 50 mils each. They say you should run these kind of tubes at 100 mils. It'll work better, but I'm not going to do that. But I made the mistake in not bringing the new drawing down here. I finalized the drawing. The screen dropping resistors for the 6SK7 and 6SJ7. To set the Zener currents, I wound up they're 20K each. So I just found a couple Dale 20Ks and I had them overnighted, and they're in here now. Didn't I say that in my last video? So all I have to do now is I just have to wire up the mic jack and the two pots, put the meter on the panel, and then put all these things on the panel. Like I said, I'm going to try to use the Molex quick disconnects on this, and I'm just going to put in the transmitter. I'm going to test the transmitter with the Keep Alive supply unplugged, just unplugged from power just to start with, and make sure this thing is actually modulating through. There's no feedback, because I may have a phase reversal thing from what I had before, and if you get it around in the wrong phase, it'll squeal back through from the microphone to the from the modulator. So I need to, I'll have to play and make sure I don't have an issue. I might have to swap these two leads here on these two. What I can do is I can swap the wire, not on the jacks, but I can just swap these guys, to reverse the polarity. So it's a simple fix if I need to. So anyway, that's what I got to do here, and I'm going to have this ready tomorrow. Put back in the transmitter and see what happens. And when I get it, the modulator, that part, the 810, the final modulator deck done, then I'll go through and I'll tweak the AVC on this and maybe get that working and everything. But for right now, you saw what I did on that last schematic. I just got the pot there for now, just so I can control the compression gain and everything. And then one of these pots will probably become the AVC control anyway. So, that's more likely what's going to happen. It won't be just to control the gain in the one stage. It'll just be the AVC, which will do the same thing, basically. It'll let that high gain go into the tube, but it won't output it. It'll reduce it. So that's what the 6SK said. It's got that super control mode feature. I found out it's somewhere between around -10 to -35 volts is where that thing activates, and you get the super control out of it. But this is great. I got everything all powered up, and all the tubes are plugged in, and I temporarily this is what I did was the 6J5 grid. I just shorted it to ground, and the same way with this red wire, I shorted the 6SK7, even though it's not coupled over right now. I just didn't want anything. I didn't want that tube outputting with no, there's no load connected on it. So that's what I wanted to make sure of. But look, I'm getting to 350 volts like I wanted it idle, and that's perfecto. So let's go ahead and let me finish this up either tonight or in the morning. When I get it in there and do the test tomorrow in the actual transmitter, I'll do one last video for that. And then the next video, I'm going to be out here with the final 810 modulator deck, and that's what we're going to be working on next. And here's my power supply idea. I'll give you a quick preview instead of cutting the video off short. This is what I'm going to do. I'm getting rid of that 5R4 rectifier tube, and this is what I'm going to do. I figured out that I can still use a small 10-watt Zener as long as it's always got around 25 mils flowing through it. And I get 50-some mils going through each one of these strings in parallel with it. So what's happening is a lot of the current's being divided off into these guys, more so on this side. But this guy is going to keep that voltage here stable, because as long as it has enough current going through it to keep this thing regulating, it's going to keep these things at the right voltage. So this is going to be perfect. And there's going to be the bias switch relay. So when I have the keep alive supply on, it'll be, it'll be going here. Like, it just needs to be a little over minus 100 volts. The things are supposed, 810s are supposed to go into cutoff like right past minus 100 volts. So minus 150, 160 will be fine on that. So, and I think these values will change, these resistance values, because it depends on two things. The first thing is, if my calculated voltage comes out there somewhere around 213 volts. Now with choke input on this thing, or with capacitor input when I calculated it, because this is capacitor input, on this thing with capacitor input, when you calculate it, with the new transformer I have in this thing, it should be exactly around 530 volts. Well, that's exactly what it came out to. I got lucky with this one. Now this one, I've used the same calculation, and it depends on if the output max get off of this. The cat's coming up here with high voltage. Dude, I got to stop him. But what I'm getting at is that, here I lost my train of thought because of the cat. But you know what I'm getting at here is that I just need to make sure I got, these tubes are in cut off at idle, and when I transmit, the relay is going to key, then this actual bias voltage is going to get on there from these two pots. And I was able to put together two more 1K rheostats. And I'll just have to tweak the value of these two resistors and this one to get everything just right. 50 some mils, I think like 53 mils going through each one of these strings, and then 25 on this one. This one was like around 10, a little bit more. I don't think it's going to take much current to put those grids on the 810s in cutoff. It may have to be a little more than this, but we'll try this first. So I'm trying to simplify the supply modification on this transmitter. I mean, on the 810 modulator rack, I'm trying to simplify, because the power supply is not regulated and it moves around. And the way I've got it, I've loaded, I put like a swapping resistor on the output to load it down to try to keep the voltage more stable. But of course, you lose current from that transformer doing that, because you're dissipating a lot of it across that resistor and it's not going to the tubes. So this, I think, is my solution. If you can see, I mean, it doesn't really matter if I use the driver transformer, because the main thing is that the 810s really need a regulated grid bias supply. That is the biggest thing that it needs. And the cathode follower mod that I was going to do on this thing would have been ideal, but I would have needed a higher voltage transformer, because I don't want to use capacitor input or a rectifier tube, and it would have been hard to have got the voltage I needed right at 400 volts doing it that way. So it's just, I can't do it the way I've got. I mean, I could, if I went to capacitor input, I would have had to put like a 5R4 tube in here to drop it way down, and it may have dropped it too far and maybe not enough. And it's better, because I know now that 350 volts at idle, when this thing is setting where it needs to set, the 6AS7 on both sides, that 80 milliamp static, that's perfect, That's where it needs to be. But the fact that I'm going to regulate the grid bias supply, this essentially might wind up being the same thing as doing the buffer mod, what I was going to do. So this is kind of my idea. Since I had the issue, since this transformer is way better than the one I had in there, and the voltage now is higher and I've got more current, so it should work tremendously better than what I had before. And with this large capacitance on the output of this choke filter on this supply, it should be pretty stable. So that's really going to help. And with this regulation, I mean, the problem when you use cathode followers, what you normally do is to regulate stuff like that, you normally take the not the operating max, but the max, the ABS voltage, right? The max voltage a tube's designed to handle, and you got to add 100 volts to it to compensate for the voltage drop, because you will get a voltage drop with the cathode follower. So you run the plates up 100 volts higher to compensate. That's how people do it. Well, that's how everybody did it back in the day, if you did it right. So, and I really don't want to run that tube at 400 volts and then to have that negative 200 volts. So I think this, in the end, is probably going to be a much better solution than what I was going to do for what I have to work with. So, this is probably going to be this will probably work better than what I was going to do. Because I don't have the 400 volts that I need and so on. And this is probably going to be ideal now. So we'll see what happens. So let's see this video. I wound up making it longer than I planned, but it's right around 10 minutes. So 73s, and hopefully if I get this all hooked up tomorrow like I plan to, I just need to do the 2 pots, put the meter on the panel, wire up the mic jack, and put the pots on the mic, on the panel, and the mic jack on the panel, and all that good stuff. And we're gonna take it in there, and if it works, I'll do a quick video to show you that it is operating. So 73s for now.